Hello, this is Paul from First Tech. In this lecture, we're going to deal with another type of a trick, of trig integral. It's the powers of tangent and the secant. Remember, the last one is the sine, the powers of sine and the cosine. So this is one we deal with the tangent and the secant put together, because we have a relationship between them, right? You take a derivative for tangent that goes to secant, okay? And they are the same. The power we have two, so two cases. Okay, this time is only two cases, and these two cases we definitely know how to do substitution. So the first case, if n is even, n is the power of secant. So we look at it. If the power of secant is even, and we do substitution of tangent. Okay, substitute the opposite. Okay, another one. If m, this power of the power of tangent is odd, it's not even. Okay, it's odd. We do substitution u equals the opposite another. Why we do this? Okay, why we do so? I will have two small examples to show you. Another. So we have a similar relationship. So cotangent take a derivative goes to cosecant, right? So we have a relationship. So and this strategy is very similar for this type. Okay, so I don't have example this for you. You can exactly follow the same idea. Now we try to get the idea. Why n is even? We need to do substitution for tangent. Okay, you can imagine like this. Can we look at it? The power for secant is even. This time definitely follow. And these results show us we need to do substitution for tangent. Why? Okay, so if we do this substitution, so tangent, if u equals tangent, this goes to use to the first power. How about this? This is complicated. Don't worry. If we do this substitution, what is du? Du take a derivative is secant square dx. Do we have a secant square here? If this is even, yes, we can separate, right? Once we separate the square, secant square, so we get a secant square dx, which is du. What do we left? Okay, so first I showed it here. So the first step by step, we can separate secant square there, right? Because we say take a derivative goes to secant square. Secant square times dx goes to du. We try to make du first. See? And we will definitely find. So these are then what do we go? Separate this. So tangent is the tangent. So secant we have first power times secant square dx. We said if we make a substitution for tangent, so this goes to du. And this u raised to the first power. How about the secant first power? This is the even, right? Original even make 2 outer with the even. Don't worry, we have a Pythagorean. We're going to make this secant 2 tangent. Okay. I mean, if we do substitution, well, I don't know. See, I should here. If we do the substitute as this suggested, u equals tangent x. Okay, we see what is this. This goes to du, so good. And this goes to u raised to the first. What we don't know is this. It's the same idea, Pythagorean. Okay, I should here is a Pythagorean again. Okay, and then if we use the Pythagorean, now what do we get? Pythagorean can make a secant square go to tangent square. This is R even number, so that's very good. So after we make all these integrand that goes to the polynomial, okay, the power function. Can you see? If we put the finally together, what is this? This is u raised to the first. This is 1 plus u square parenthesis square. Okay, later I will going to show you detail. So it goes to the polynomial. Okay, goes to the polynomial, which is a power function. That's easy, right? What this du? Can you see? Because very easy. This is easy to get it, right? It's very similar idea as we did for sine times cosine. Okay, now is the second one. We look at the second case. If m is odd, if the power of tangent is odd, is this odd? Yes. So we're going to find the basic idea. Okay, here is odd, the second case. Look at the suggestions. They need to do substitution for another secant square. So how do you think? Take a derivative of secant. Derivative of secant is secant times tangent, right? Secant times tangent. I mean, we can separate one tangent, one secant, make times dx together. So that goes to du. Okay, the same as this. Okay, so we can do this. This time, what do we need to separate? We need to separate one secant times one tangent, because this times dx is du. Okay, that's the reason why we need to separate this. After we separate, see what do we have? We will have tangent square now, and this is a secant fourth power times another secant that goes here, another tangent that goes here, and then dx. You remember why we need to separate that? Because when we do this substitution, we follow that. We substitute the u equals secant x. So this goes to du, definitely. Okay, and all we need to do is, does this make a u? This make a u. Can this make u? Yes. This we have Pythagorean. Tangent square is secant square minus 1, right? Okay, so I follow this. We also can make a u. This, the name is a Pythagorean. Again, right? So after use the Pythagorean, we finally, what do we get? Is get the same as this. We get the polynomial of u and then du. Okay, so here it's the same again. This is a polynomial. I mean, this both we can do calculation easily, right? Because they are polynomial, power function. After we get the u, back substitute, we can get x. Okay, this is the idea. Now I have two examples. Each case I show you completely. Example here. I think you remember what the basic idea, right? So can we look at this one? Okay. So first, and this is not odd. This is even. Okay, that's good. The first case for the results I just showed you, and the power of secant is even. That means what? We can do substitution. We would do substitution for u equals tangent, right? So if you do that substitution, du equals secant square, we need to separate it. So okay, we do this. For this, we have to separate secant square to make a du later. So after we separate it, can we see? So these are going to put there. Okay, equals this integral tangent is dr tangent, right? So secant we separate the two, left the two here times secant square dx. Remember, so this is du, and we want to do substitution for tangent. So this is not a tangent. This is tangent already. U raised to the 6. So what this? Pythagorean, right? Remember that. So this we have to use Pythagorean. What is the Pythagorean? Okay, we can make a secant square goes to tangent square, which is 1 plus tangent square. Okay, another type of Pythagorean you learned from trigonometry, famous. And then we will have this. Can we see? Can we see? Tangent raised to the 6th power still there. This goes to parenthesis 1 plus tangent square, right? Times secant square dx. Now is ready for substitution, right? Remember the substitution. This is even we substitute the tangent. So up here we do this substitution. U equals tangent x. If we make a tangent there, what is du? Definitely is secant square x dx. See, that's here. We already make it ready. Okay, so for your substitute. So we put here. This is a du. Good. What is? This is a polynomial of u, right? This is a polynomial of u. That's what we just demonstrated. Okay, and now it's easy. We just do integration for polynomial. So this is the u raised to the 6. This is 1 plus u square, and this is du. See how easy. Now is distributed. We will get 6 plus 8 and du. Each one is the power, right? So the first is 1 over 7 u raised to the 7. Second is 1 over 9 u raised to the 9. Don't miss plus c. And also this u we need to back substitute, right? Remember that. So we go to x. So we substitute what is u? Tangent. So what do we have? Is tangent raised to the 7th power at x plus tangent raised to the 9th power x plus c. See, this is already sorry. Okay, the last one is just a back substitute. You can see. Okay, so I have one more example, very similar with this. I think if you get the idea, it should have been difficult. So now we're going to this example. Okay. Secant square, we look at the power. This power is not even, so it's not belongs to the first case, it belongs to the second case, because the power of a tangent is odd. Remember, if this is odd, so what do we do? And the result shows we need to do substitution is secant, the opposite. Okay, secant, and the secant is u. Take du is goes to secant x times tangent x times dx. So we need to separate the one this and the one this to make dx together to make du, right? Okay, I just say separate. Now separate secant x times tangent x. Okay, all the purpose is to make the substitution ready. Now, and I put that to here. What do we get? So this make one out. We have a tangent to the force left. This take one out. We have a secant force also left. Then times secant x times tangent x and times dx. Can you see? This is what? This is du. So this is u. How about the tangent? We have a Pythagorean, right? So this we can make it to secant. Okay, is the Pythagorean. You know the Pythagorean it is. So tangent square we can make into secant square minus 1. See, this we also can make it to secant. After the substitution, this goes to everything is goes to u. Okay, so we just do. So what is the force power? Force power is the second power's power. Okay, and so we can get it secant square minus 1 parenthesis. This is tangent square, square of square. Okay, so this goes to tangent to the force, and so here we have a secant to the force x, and then times secant x tangent x dx. Ready, right? Totally ready. Remember, so our purpose to get this, because the substitution is this, right? U equals secant x. So can you see? Okay, so now you're going to find that du exactly is there. So du equals secant, take a divided with secant x times tangent x times dx. Okay, so this is du. Good, we do have du here ready. Okay, and the u is secant. So this is what? This is a polynomial. Okay, a polynomial function of u. See, this is a pu, polynomial of u. That's good. And now do the simple way. Plug everything in. So that's a u square minus 1 square times u raised to the force du, right? The symbol is the integral, but we need to expand. This is the perfect square. Okay, you expand. You know how to expand. After the expand, I get a u raised to the 8th power minus 2 u raised to the 6th power plus, okay, plus u raised to the 4th power and the du. See, just expand. This is the power. Okay, so we have the first is 1 over 9 u raised to the 9th power minus 2 over 7 u raised to the 7th power. This is a 1 out of 5, right? U raised to the 5th power, okay, and plus a constant number. The last step, is just a back substitute. So back substitute, we get 1 9th. U is secant x, so we have secant 9th power, okay. Then minus 2 over 7 secant over to the 7th power plus 1/5 secant raised to the 5th power and plus c. Yeah, sorry, it's almost you cannot see, so look at after this substitute you get and this is the final answer. Okay, thank you, that's all.